Hi Maria. So this is the Jamovi window that I've opened. So I've a couple of points. Mine's on a PC, so it might look a little bit different if you do it on your Mac. And I installed a few months ago what was then the stable version 1.2.27, and it's now 1.6 point something, which is the latest version. So you can try with the latest, um, and if there's some issues, go back to the stable and reinstall the stable version. The second point is that I've already installed for my later video the toaster. This is the equivalence test module. So you probably have far fewer modules because you can add extra ones. So you go here and then you manage the installed, and then you look at the available and you find toaster in there and then install it. So for me it's already installed. There it is. There. It was actually just basically the same thing in Jamovi that he provided in R. So that's something you should do, install that. Everything else, you shouldn't need anything extra special modules. Okay, so the nice thing is you can open, it's like SPSS. Here you've got your data window and here's where the output goes. Jamovi is really nice to use. Anyway, so I'll open a data file. Maybe I have to import it. Maybe we can open it. It doesn't really matter. So you browse it, and here's the ASI combined. I didn't. It's in my. It was yesterday in my downloads. Yesterday. Oh well. So you would just find the ASI combined SPSS file and open it. Maybe I already. So it's not there. It doesn't matter. Oh, here we go. Yeah, I see a recent one. So I'll open it. ASI combined. It opens it. And it produces all the variable names. Everything looks nice. So remember, we're going to need to sort the data by experiment. So manually, I just coded in the first 148 as a 1 and the second as 2. So you just open that file, which I saved as a Jamovi file, ASI combined OMV. I'm going to open that. I'm going to close the other one. We only need one open. And sometimes it just takes a while to fill in all the numbers. And I called it study num. You can edit a variable. If you go in the data window, you can edit a variable. I gave it a number and I gave the levels 1 and 2, and you can change various things. When you create that, it will just come up with some, call it A or something, when you just change it to study number. So you're in the data window to do that. And there you can do filtering, which we'll come back to. Well, actually, I've created a filter. Let's do it. Or we're in the data window. It's inactive. And so you can make it, the filter can equal study num double equals 1. So equals, and you make it active. So now, close that filter. See the first 148 when study number equals 1 are now selected with the green tick. Because we're going to start with study number 1. There you go. And they're red crossed out. And we're going to essentially look at each group separate, each experiment separately, and then combined. So we're now ready to run an analysis. And these are Bayesian correlations. So we go to the analysis, and it's in the regression drop-down menu, Bayesian correlation. You do it just as pair to start with. You want to do it repeatedly, and it starts filling out the output. There's nothing there. So the ones I did, I'm going to ask for various options, which I'll kick in a minute. So I'm going to look at the extroversion variable correlated with, let's do the one I did in the file I sent you, which is the friendly extroversion advantage. Okay, so it's calculated a Bayesian correlation of 0.2 and it's got a Bayes factor of 2. But we're going to ask for some credible intervals. There they are. We get some plots. We can ask for the scatter plot. We'd like the posterior and prior. and we'd like the Bayesian robustness check. We click those, and we're working with it correlate with one-tailed. In most cases, these analyses have got a direction, so I'm going to predict correlated positively. If it was neuroticism, it would be correlated negatively. We're going to look at the Bayes factor for the alternative relative to the null. They're just related to each other by a factor of 1 over. That's what we set, and then we get a nice, we get the data windows that I talked you through. The scatter plots quite nice. They are not specific to Bayesian. They apply to the correlations. You might, I think I suggested putting those maybe for all these analyses in an appendix for study 1 and study 2. They show, show the whole data. This is, remember, just study 1 because of the filter. Now, as I explain in the text, we can control the prior here. It defaults to something called the stretched beta prior width of 1. And if we look down, we see it sets our expectations for the correlation value. And because we're doing it one-tailed, they're all positive between 0 and 1. But it says we have no hint of completely uniform, uninformative. We have no expectation for where the correlation would lie. As I explained, that's not very realistic. And so before I looked at the data, I chose a prior that I think is more realistic, bearing in mind correlations tend to be around 0.2 for traits of behavior in individual differences. So we want a prior that bumps up most of the correlation down this end and doesn't have many really high correlations because we just don't get them. So by playing around, I found that the value which I think we should use is 0.15. And so what's nice about Jamovi is if you change something here, this layout just changes. So I'm just going to hit that and it will redo that. And you see this is the prior. It's saying the correlations, most of the probability of the correlation lies between 0, 0.25, and there's hardly any really high correlations expected. It's a bit arbitrary, but I mean, I'd prefer to have one that was, kind of maybe a bit more peaked, but this is the limit that Jamovi has. So this is our basic, and so I didn't pick this to get convenient results. I picked this prior because I thought it was reasonable. And this now does the overall correlation. This is what we were expecting without seeing the data, and this is what the expected posterior distribution for the correlation is after we include the data in study 1. So it's clearly shoved the correlation more above 0, and it's more peaked around this central tendency value of plus 0.19. And it gives so-called CIs, and for Bayesian analysis, these are referred to as credible intervals rather than confidence intervals. And clearly, there they are. The range doesn't include 0. So this analysis shows that after seeing the data, our belief is 95% credibility that the correlation is above 0. And now we look at the Bayes factor, and this is for 1, 0. The 0 is that the correlation is the hypothesis that the correlation is 0, and plus, or 1, is the correlation that is the alternative hypothesis. It's got a plus here because we've done it here. If I change this to a two-tailed, it would just use 1, 0. But we're looking two-tailed, and I've changed it back. We're looking one-tailed. So you see that the Bayes factor is 9.3 in favour of it being above 0. And you remember a Bayes factor of 10 is generally regarded as strong evidence. And they use it. What you see now is we can actually look at the Bayes factor robustness check, which sees how much the Bayes factor depends on the choice of the prior, which we've set here. So here we see our prior, we get 9 point whatever it was, 26, and actually it's all high at this end. This is the highest value. If we'd happened to choose 0.065 for our prior here, for our prior width here, then we'd have had an even stronger Bayes factor of 10.14, but we had 9.263. But even when we make the very unrealistic assumption of here of 1, which is uniform, as I showed you, the prior is, for the prior, the Bayes factor is still well above 3, which is the moderate evidence in favour of H1 or H1 plus as it is here. Okay, so it's not that dependent on the prior. It's clearly evidence between moderate and strong, whatever choice we make. And I really think it's not sensible to choose a completely uninformative prior of a value 1, which loads uninformatively across the whole range of possible correlation. Let's just see what actually is exactly if we put 1 in, get the same sort of plot. 4.2. So it's well above 3. It's well into the moderate range, even with the most uninformed choice of prior. Okay, so let's put that back to 0.15. So just to show you how you would do this, so easy. Now so you can then basically go on these figures, particular analysis, you can copy them and then paste them into your document rather nicely. So and then you go down to the other one up here, you can then copy it, and so on, which is really a nice feature. It's important because if we change things, we're going to overwrite these, and that's the summary there, which you've already got. So what I'm going to do now is do the filtering. So now let's do some filter. So that is a data operation. Click to data. I'm going to filter, and I'm just going to change this to 2. Now this is just the 62 subjects, maybe a couple fewer if they were missing their extra version score. Here, you just hit return, and then we stick that up, and this will redo it in here for just the study 2. Okay, the important thing to do is remember to save any plots you want before you do the filter, because it will overwrite the previous ones. Okay, now you can see here the correlation actually larger in study 2. The Bayes factor is more modest given the smaller sample size, but it's at 3, the border of moderate. And again, it doesn't include, the range goes from 0.02 to 0.4. It's clearly positive. We're pretty confident it's above 0 from this. Okay. Now, this is our equivalent plot here, and so on. And we see, even here, we're getting at this end of the scale, we've clearly got, there's never any evidence that it would be except with these ridiculous prior values up here, which put most of the expectation of very high correlations, 0.98, 0.9, a stretch prior of close to 2, then, we're clearly in, whatever we do, we're in evidence for the alternative hypothesis of a positive correlation. And for our value, which we chose without looking at data, we get a value 3, which is on the border of the low range of the moderate range. That's exactly as we expect. So now we can put the filter in and remove it. So it's for everybody. And what we'll see, we'll hide that, we'll see we now get very strong for the combined sample. The correlation sticks around, still around 0.2, doesn't change, but the Bayes factor has gone up to 31, and that's in the very strong range here. And there even would be a stronger 31.3 and nearly 34 if we'd chosen, the 0.0825, but we stuck with 0.15, before looking at the data. Now, so that's really all there is to do. You just got to do it repeatedly for all the different correlations. Now, two things. One, there's no approved method for correcting for multiple comparisons because the logic doesn't apply to Bayesian statistics. But I comment on that, look at that in the text. You need to comment on that at some point. Now, there's an extra feature here, which I'm going to go on, analyses. I'm going to if you just click on this, it throws you back to the analysis window from the data window. Now, there's something here which we haven't used called sequential analysis. So this going through the subjects in the order in the data file, so it's an arbitrary order. I mean, you could randomize them and do it again, will give you the plot of the uh, Bayes factor subject by subject. So we just click that and it creates an extra plot you can now get, which actually is quite informative. I explain the background to sequential analysis and I'll give you a reference in my notes. So here, this is the first sample one subjects, which end just about here. Notice that as you add subjects in this arbitrary order, there's always positive evidence for H1. It's mostly in the moderate to strong, in the moderate range here, but by the full sample, but you need almost the whole sample, it just goes into the close to or the strong range with our 0.15. Okay, so that's really nice. Okay, that's useful to have, showing that it's not, it's not darting around depending on the subjects. Unlike, the MOTVID, where there are different subjects contributing degrees of fit. Now, what's nice is here we add the subject 2, the experiment 2, so it's somewhere here, and we add the remaining 60-ish subjects. What we see is there's a steady increase for again, it's an arbitrary order, but there's no persistent, it doesn't go up and then go down. It generally steadily increases, and it never drops. Well, maybe just here with one subject below the strong. So it starts close to the strong range and it never drops into the moderate range. So, adding all the subjects and then it ends up in the very strong range. So adding subjects from experiment 2 shows that, this doesn't change the fit. I mean, if it started to decline or ended up at a much lower place, that would be suggestive that the evidence provided by sample 2 was weaker than, was weakening the overall evidence. Here, even though individually subject study 2 produces weaker Bayes factor, what it does, it continues the pattern shown in study 1. So this is quite a nice way of showing, I think, even though it's not a formal sequential analysis, it nicely shows that our sample 2 is essentially for this particular correlation, and it will happen for several of the others as well. All the ones with extroversion, I think, it will show that sample 2 behaves pretty much like sample 1, therefore ruling out some of the artifacts. So I think it's a really nice little extra feature. But you only need it when you look at the full sample. So that's really all there is to say about sequential analysis, about Bayesian correlations, and a little bit about sequential analysis. So I'll stop there, send you this video, and tomorrow I'll show you how to do equivalence tests in Jamovi using this toaster package for MOTVID. Very, very simple as well, really nice and easy to do. Okay, I'll stop now.